Allee Effects Under Climate Change by Brooke McKenzie. The question we're addressing today is, how is the Allee effect altered with the continued pressures of climate change? As we know, climate change has been accelerating at an unprecedented rate, and the impacts it has been having on species around the world is a necessary area of research. Whether it be the effect climate change has on habitats or species interactions, it is decreasing biodiversity and increasing extinction rate. In 2015, Urban found that 1 in 6 species could go extinct due to the changing climate. They also found that the regions with the highest risk of extinction are Australia, New Zealand, and South America. Here you can see a picture from the Australian wildfires, which have destroyed the habitats to countless species, increasing their possibility of extinction. The Allee effect describes when a population is so small that their extinction probability is absurdly high. The death rates rise and the birth rates fall at the low population numbers. You can see in the middle graph how a weak Allee effect causes the population growth rate to flatten at low population sizes. In the top graph, you can see how a high Allee effect even causes the growth rate to become negative at the green dot, known as the minimum viable population size, driving the population to extinction. Some of the causes of the decreased birth rate can be because mates are less likely to find one another or an unequal sex ratio, while the increased death rates could be due to inbreeding depression, stochastic effects, decreased foraging facilitation, or less cooperation to protect themselves from predators. A pack of lions is a good example of a group that forages together and would be affected by a low population size. The Allee effect relates to climate change in that climate change puts populations at greater risk of extinction, and the Allee effect describes the increased extinction probability of small populations. If there is a relationship between climate change and the Allee effect, the rate of extinction expected with climate change could be further exacerbated by a stronger than expected Allee effect. In 2017, Harsh created a spatially explicit moving habitat model to show the dynamics between the changing climate and various factors, including the Allee effect. In this figure, you can see that there is an inverse relationship between climate change velocity and the Allee coefficient. A higher Allee coefficient correlates to a more severe Allee effect. So overall, they found that in order for a population to remain intact and avoid extinction, the severity of the Allee effect must decrease as the speed of climate change increases. We can infer that if no drastic actions are taken to slow climate change, populations with a constant Allee effect will be more and more likely to face extinction. In 2019, Winter and colleagues used an age-structured model of Atlantic cod to show how the Allee effect can change under fishing and climate change. In the figure on the left, you can see that adding the Allee effect with 1 degree Celsius water surface temperature rise causes the population growth rate to decrease drastically, making it more difficult for the population to recover if it gets close to that Allee effect threshold. With warming of 2 degrees Celsius, the growth rate and the chances of recovery are even lower. In the figure on the right, you can see how with no Allee effect, increased warming decreases the rate of fishing that can occur without collapsing the cod population. Then adding the Allee effect causes the whole graph to shift to lower rates of fishing without population collapse. This is evidence that the Allee effect exacerbates the effect global warming already imposes on populations. In 2019, Barrett created a gypsy moth population model and found that warming makes the Allee effect stronger. In analyzing these figures, it is important to point out that the variable P is pesticide efficiency. However, we will only be focusing on the overall trends. In these graphs, the higher the Allee threshold, the stronger the Allee effect. Panel B shows that the Allee threshold decreases as temperature increases due to the parameter of mating rate. Mating rate takes into account a higher male-female encounter rate as temperature increases and modifications in adult emergence due to temperature. Although Panel B shows the Allee effect weakening at higher temperatures, Panel C shows the opposite due to the parameter of mortality rate, which increases as temperatures increase. Combining these two parameters, you see Panel D, the Allee effect due to finding a mate. This indicates that overall, warming strengthens the Allee effect. In that same article, a second model was analyzed considering the Allee effect driven by predation. In this figure, the red is a weak Allee effect, the green is an intermediate, and the blue is a strong Allee effect. The trend is shown that at higher temperatures, the Allee effect is lessened. As temperatures increase, a larger and larger section of the graph is taken over by the red, indicating that predator biomass densities move from having a stronger Allee effect at low temperatures to a weaker Allee effect at higher temperatures. This model contradicts the past models we have explored, so it is an important result going forward in analyzing the effect climate change has on Allee effect intensity. Overall, various study groups have found the same result, that the Allee effect is worsened by increased climate pressures. This means that the detrimental effects climate change is already having will only get worse because of this natural phenomenon known as the Allee effect. Populations will have a much harder time recovering if their populations reach the Allee threshold than they would have without climate change. The prediction that 1 out of 6 species will go extinct under climate change will likely rise now that the Allee effect has been taken into account. Here you can see some of the species that have that unfortunate fate. Now, despite all the studies we analyzed having a similar result, the final study also found that the Allee effect driven by predation actually weakens with temperature increase. So depending on the population and what challenges it faces, the effect climate change has on it could differ. If the population is reaching dangerously low levels because of predation, they may have a better chance of recovery with climate change. However, if the population is decreasing due to habitat loss, they may have an even harder time recovering with climate change. To continue research on the Allee effect under climate change, it is essential that all of the models we explored are tested in a field or in laboratory experiments to verify their validity. Perhaps using a small model organism like rotifers in the lab would be a logical first step, since they have a short lifespan and climate change could be mimicked. You have the ability to add a predator, change mating ability, or create inhabitable patches to mimic climate change. While this is a very challenging relationship to document due to the nature of climate change, it is a necessary next step in order to prove a tangible relationship or causation.